Oh my goodness, where has the year gone? I can't believe it's Tuesday of Regents Week and we're 3 days away from the big exam. So very excited, the juices are flowing. And today we're going to try to cover just about everything you need to know about logs minus a few details that we couldn't quite squeeze in. Real quick, this table here just kind of reminds you of some of the rules. Hopefully these exponent rules look really familiar. And then these logarithmic ones are the one we're going to focus on. If you go from the left side to the right side, that's called the expanding side. If you move from the right side to the left side, that of course is your condensing side. So we're going to practice those a little bit. Here's a multiple choice question that incorporates a few concepts throughout the year. They want us to condense this particular expression up here. And the first thing I jumped on was that minus sign. So what I'm going to do is I'm going to condense those two log terms into one log term. And it's going to be the quotient of cosine over sine. And then just when you think you're all done, you recognize that what's inside the parentheses here is a special identity from our trig chapter. So we're actually incorporating a little bit of trig tonight. Who'd have thought that was legal? And so we just simplify cosine over sine to cotangent, and we fall in love with choice 4. Here's a particular brand of question that we've kind of struggled with, and the big key here that we want to talk ourselves, they never said that a was equal to 3. What they're saying is that a is equivalent to the expression log of 3, the entire quantity itself. So, but anyway, we need to rewrite the log of 12. And so the first thing I was visualizing is that 12 could be rewritten as 4 times 3. And I'm going to use a log property to expand that, log of 4 plus the log of 3. And then I'm going to rewrite my 4. That's really a 2 squared. And so we're going nice and slow in slow motion here. And then we could use our third log property that says, hey, this exponent can become the coefficient in front of that term. And so we get this kind of expansion. And then you'll notice that the log of 2 is really b plus, and the log of 3 is equivalent to a. So 2b plus a, let's see, this one right here is equivalent. It's not in the same order, but it certainly is equivalent to what I have. Well, for the first time tonight, we finally have an equation here, all of a sudden with our equal sign, and the directions simply say it's that one S word, solve. Now, before I get too excited and start tackling this logarithmic equation, I want to identify our restricted domains. If you look at the first term, that kind of informs us that x has to be greater than 0, and then the second term right here informs us that x has to be greater than 3, because those quantities have to be positive. All right, they can't be 0 and they can't be negative. So let's just kind of stick that in your back pocket. The next thing here is that you'll notice there's only logs on one side. Okay, that's important. On the next example, we'll see logs on both sides, and that's going to change our plan slightly. But either way, your first move is to condense both sides as completely as possible. So on the left side, I see a plus sign, so I'm going to rewrite it as the product of x and the quantity x minus 3. And of course, I'll distribute that x here in a moment. Now, there is an invisible base that you cannot see right now, and hopefully you're screaming at your screen right now saying there's an invisible 10 right down there. So what I'm going to do is I'm going to convert this logarithmic expression into exponential form. I'm going to circle my base and I'm going to say 10 raised to the first power equals the quantity x squared minus 3x. From here on out, you've just transported back to 9th grade. We're going to solve a very basic quadratic equation. We know that 0 equals x squared minus 3x, and you're probably already done with this one and ahead of me, and that's great. Let's see, so as I tee that up, I've got x equals 5 as a solution and x equals negative 2, and the debate begins, can I keep both of those solutions? You'll notice back here at the beginning with our restricted domains, we said x has got to satisfy both of those domains, and so therefore I'm going to reject the negative 2, and my only solution is positive 5. In our last example tonight, we do have logs on both sides of the equation. My first move, regardless, though, is the same, and that's to condense as much as possible. Oops, I almost forgot. I want to talk about our restricted domains. We've got a quantity here that says x has got to be greater than 0, so if we do get any negative numbers, we're going to reject them this time. There are no other variables in our log arguments, so we don't have to worry about those other terms. I want you to get in the habit of locking in on those coefficients right away. Let's move those coefficients to the exponent instantly. And you'll notice that's the only thing I'm going to really worry about on my first move is just moving the coefficient up. and then we'll condense. When I see the minus sign, I'm going to condense these two log terms into one term. It's the quotient of x squared and 2. And then here's our favorite part, because we do have logs on both sides. Unlike the last problem where we had to convert it to exponential form, we're just going to kill those logs. And we're going to say that x squared over 2 has to equal 18. We'll cross multiply, and we've got x squared equals 36. Now, as I take the square root of both sides, I'm actually getting two solutions. As I take the square root of 36, I'm getting both positive and negative 6. However, if you go back and look at your restricted domains, we said that x has to be greater than 0. So we'll reject the negative 6, and positive 6 is my one and only solution. Okay, here's the much anticipated extra credit for tonight. Let me help you sort out this crazy looking page. Up here is question number 1. It is a multiple choice question, but I'm asking you, as you condense those terms, to show me all your work. So you're going to have to show 2 or 3 steps there to earn credit. Number 2, again, even though it's multiple choice, show all work. Number 3 down here, the directions simply say solve. All right, focus on your domain, see if you have to reject anybody. Number 4 over here is another logarithmic equation with logs on both sides. Again, the directions just say solve, watch your domains. Then the 5th one tonight's kind of a treat, okay? I haven't done an example, I didn't do one just like this, but trust me, you've got all the talent and the ingredients necessary to tackle this one. I did end up with 2 solutions for number 5, that's my hint. One of them was very clean and the other one was a fraction, and then you have to check them to see if you're going to keep them or not. But I especially challenge you with number 5. I hope you can rise to the occasion and tackle this very challenging rascal. Good luck.